Today we are going to talk about solving inequalities by adding or subtracting and solving inequalities by multiplying or dividing. So copy down your target for today. I can solve one-step inequalities by using addition, subtraction, multiplication, or division. Pause the video to copy this down and answer your 3 warm-up problems, and then you can click play when you're done. For the first warm-up problem, what are 3 ways you could say x is greater than or equal to 5? You could say x is greater than or equal to 5. You could also say x is not less than 5. If it's not less than 5, it has to be greater than or equal to. And we could also say x is more than 5 and including 5, or more than or equal to. Either one of those ways. So if you say and including 5, that says it can be equal to it as well. For the second warm-up, if x is greater than y and y is greater than x, then x must be greater than y. I want you to put this down. This is actually kind of like the transitive property. You're going to see this a lot next year in geometry. And for graph x is not equal to 5, hopefully you have a number line. We want to show that it can be any number except for 5. So I leave 5 open, and you can shade both ways on your graph. And if you want to shade above the line or on the line, I don't have a preference. I know some of you were taught different ways in the past. Whether you shade above the line or on the line, both are fine to me. Okay, so let's get into some of these examples for today. Copy down your problems. Each of these are going to have one step to solve, and we solve inequalities just like we solve equations. So keep in mind, you're always trying to isolate the variable by undoing what's being done. Use inverse operations. For the first example, in order to get d by itself, you would add 38 to both sides. When you add 38, they cancel on the left, and you have d is greater than negative 22. You have a negative 60 and a positive 38. Remember, you're doing 60 minus 38, and then since the sign of the larger digit is negative, your answer would be negative. We should do a quick check step over here. So if I do negative 22 minus 38, I would get a negative, let's not check the end point because that's not an answer, right? Let's check at any point that's going to work. So let's do our graph first. D has to be greater than negative 22. So I might have negative 22 over here, negative 24, and negative 20. And we're going this way. Where are my solutions greater than negative 22? Open on the negative 22 and heading towards the positives. So choose any number in that solution region and try it out. Make it easy, guys. Don't work harder than you need to. What's an easy number that's in that solution set? 0. So if I plug in 0 minus 38, I want to know, is that greater than negative 60? Well, negative 38 is a larger number than negative 60, so that does check out. On the next one, undo what's being done. We are adding 0.495 to n, so let's subtract it from both sides. They cancel on the right, and you have n. We're keeping the symbol the same there. And now we just need to subtract these decimals. We're going to have to carry a little bit. And then I always like to rewrite it so that my variable's first. I'm going to turn this around then to say n is less than or equal to 237 thousandths. I think it's better to write the variable first because when you're graphing then, some of you may have learned a little kind of cheater step. You can shade whichever way this is pointing if the variable is first. That only works if the variable is first, so if I were you, I would rewrite it to help you out. So we can graph this one. You can count by whatever, so keep that in mind, but we want to see this number on the number line. So I'm going to space these out because they take a little more room here. There we go. And it's including this point now. So I'm going to fill it in. I want the numbers less than that, so I'd be going towards the negatives. Okay? Quick check step. What's an easy number to try? I would try 0 again. If you can try 0, or try -2 or something like that, but I'm going to do 0. So 732, is that greater than or equal to 0 plus 0.495? Yes, it is. Okay? You can show more lines in your check step if you want. I don't require it. When you are graphing, when you finish your inequality, you should always check the end point to make sure, should this be filled in or open, and the direction of the inequality symbol. The direction is going to tell you which way to shade. Okay? Try to just think in the general sense, where are the numbers, on this example, where are the numbers less than this decimal? And on the first example, where are the numbers greater than -22? You can always try a point if you don't know how to shade, and that'll get your answer as well. Next example. You have a word problem. We can use inequalities to solve these. And we've actually already done this a little bit. If you remember the write about in chapter 2, it dealt with a price being below a certain point. The memory in Eliza's camera phone allows her to take up to 20 pictures. Eliza has already taken 16 pictures. Now make sure you read all the directions here. I want you to write, solve, and graph an inequality to show how many more pictures Eliza could take. So you have to write an inequality. Anytime we have a word problem, if we're writing an inequality, we need to define our variable. So what variable is going to make sense here to use, and what is it going to represent? Well, reading this problem, we're talking about photos. Hopefully you kind of highlighted that. That's something important. So I'm going to have, let me get a darker color here, I'm going to have P stands for photos. The number of pictures she can take. Eliza has already taken 16 pictures, and she can take up to 20. So hopefully you see that as important as well. If she already has 16 and she can take up to 20, our inequality to represent this situation might be P plus 16 should be less than or equal to 20. This represents the photos on the camera. And this represents the total of how much it can hold. Okay? Once you have your inequality, you can solve, undo what's being done. So I would subtract 16 from both sides. They cancel on the left. You have P is less than or equal to 4 on the right. I also have to graph this. Now, think about this word situation. Can we take part of a photo? Can we take a negative amount of photos? We cannot. So you want to make sure your graph shows that you can't go into the negatives and that you really have to take a whole picture. You can't have part of a picture either. How would you graph that? Think about that for a second. Since I want to go down to 0, but also show 4, make sure that's on there. She can take 4 pictures and still have enough room on her camera. She can take 3 pictures and still have enough room on her camera. She can take 2, she can take 1, or she can take 0 additional pictures. So there's your solution range. You might want to add one more number on the other end to show that we're not including it. They can see that this is, it's not going to be a pattern that continues on. This is the only range of acceptable answers. So you always want to think about reasonable solutions whenever you have a word problem. That might be something to write down. Remember what's reasonable. We talked about this whenever we did percents. If you remember, I said always check your answer and ask yourself, does it make sense? Is that possible? We can't take a negative amount of pictures, so you would want to only show that up to 0 on your graph. There is one difference between solving inequalities and equations, and some of you might remember the rule. Well, when solving an inequality, if you multiply or divide by a negative, you must flip the sign. But I want to know why we have to do this. So we know the rule. A lot of you already have an understanding of that. But why? Why does that happen? Why do we need to do this? Why can't it just work out where, you just keep it the same? Well, I want you to think about two positive numbers. I'm going to put 0 on the number line so we can see this. A is going to be over here, and B might be a little bit higher than it. Okay, think about where those numbers are right now. Because of their position on their number line, which number is greater, A or B? Hopefully you said B, so we can say B is greater than A here. Okay? Well, keep in mind in math, we have that multiplication property of equality. You can multiply both sides of an equation by the same number, and it keeps the equation the same. So let's multiply both A and B times a negative 1 and see where they would end up. Well, if I do B times negative 1, I would have negative B, and it would be like a reflection over the x-axis, over the 0. So it would reflect over, negative B would be over here. And if I have A times negative 1, I would reflect it over, and it would land right here. Now looking at your points in pink, which number is larger, negative B or negative A? After multiplying by a negative 1, which number is larger? Well, if you look at it, negative A is greater than negative B. Or you could turn it around and you could say negative B is less than negative A. Those are equivalent. Take a look at what happened here and comparing that to here. You can see that if we want to keep B on the left and A on the right, and we multiply both sides by a negative, we must flip that sign. Think about what negatives do when you multiply by them. If I have a positive number times a negative number, I get a negative number. And if I have a negative number times a negative number, I get a positive number. So maybe notice a trend here. Whenever you multiply by a negative, the sign of your original number flips. If you had a positive, it's now negative, and if you had a negative, it's now positive. So I know a lot of you know this rule, but I want to make sure you understand why this rule exists. Make sure you're clear on that. Draw these diagrams, maybe write a little sentence if you need to. Okay, I'm going to pause the video and make a new one because I have a 15-minute limit on this one. So you will have a part 2 for this lesson.